Hello everyone and welcome. In this video sponsored by Retail Me Not, we are continuing along with the theme of testing air filters. So in a previous video we tested the original equipment air filter in my Subaru Crosstrek, and then we also tested it against performance air filters. And so in this video we're going to be determining whether or not charcoal air filters, which is an additional filter within the intake system, actually make a difference for performance. And so the way that we're going to be testing that, same as the previous video, we're going to be testing on a dyno, measuring horsepower and torque, and then we will also be using a V-Box to test real-world acceleration with and without using this charcoal air filter. So we're going to test it using the original equipment filter, and we're going to test it with and without this charcoal filter using a performance air filter. Okay, so the first and most obvious question is, what is a charcoal filter and what is it for? And so this is sitting within your intake. So your air is going to come in from the front of the vehicle. It is then going to pass through your air filter. And then after passing through that air filter, behind it is this charcoal air filter. And the reason this exists is actually to prevent hydrocarbons from escaping from your intake and going back out into atmospheric air. So why would that happen? Well, think about when you shut your car off. So you could have your positive crankcase ventilation system vent some of those fumes from the crankcase into your intake tract. You could also have those fuel injectors, which are port fuel injectors, spraying fuel before the intake valves. You shut the car off, there's still some fuel sitting there in the intake tract. So that fuel could work its way back up the intake and vent to atmospheric air. And so this charcoal air filter is what captures that fuel and prevents it from escaping into the atmosphere. Now, as you may have figured out, that means this charcoal air filter is a piece of emissions equipment and it is not intended to be removed. In fact, removing it is a permanent process. It's not a reversible process in taking it out. You have to actually cut some tabs. And so what this means is, you would not be emissions compliant if you were to take this off. So for a road car, for a street legal car, you would not want to do this. Of course, it would vary depending on which state you live in, but typically the case is do not tamper with emissions equipment. For all the Subaru Crosstrek track owners out there that are tracking their Subaru Crosstreks, I'm sure it's a huge crowd. This is going to provide plenty of insight into what happens when you do actually take this thing out, which again, you should not do unless you are specifically tracking your car, not using it on the road. Now, as mentioned, this is a continuation of the previous video on air filters, and once again is sponsored by Retail Me Not. Now, if you're using websites like Advance Auto Parts or Amazon, whatever it may be for buying car parts, you'll likely notice that there are all kinds of coupon codes floating around out there to save money. The free browser extension Retail Me Not is designed to compile all of those codes and make sure you're getting the best deal on the product when you check out. So it can be really helpful in saving some money. I have a few videos coming up which I'll be using the tool for, and I'm excited about the ongoing partnership. Every little bit helps. You can find a link for the tool in the video description if you're interested, and it works with all of the major browsers out there. All right, let's jump right into the dyno testing. So each option had 3 dyno runs, and then we're going to be comparing the top horsepower and torque figures from the best dyno run for each. So with and without the charcoal filter, and then for both the stock and a performance air filter. So 12 total dyno runs here. And so our first option, stock filter with the charcoal air filter installed, 160 horsepower, 137 pound-feet of torque. Then we removed the charcoal air filter, just running with the stock air filter, 164 horsepower, almost 142 pound-feet of torque. So an increase of 4.1 horsepower by removing this charcoal air filter, as well as 4.4 pound-feet of torque by removing the filter. So 2.5% more horsepower, over 3% more torque, and all we did was remove this charcoal air filter. Next, we ran the test with the performance air filter and the charcoal filter as well. So both filters were looking at 164 horsepower, 142 pound-feet of torque. Then we remove the charcoal air filter, leave the performance air filter, and we are looking at 167 horsepower, 143 pound-feet of torque, an increase of 2.7 horsepower and about half a pound-foot of torque, and that means 1.6% increase in horsepower and about 0.36% increase in torque without running the charcoal air filter and using a performance air filter. All right, so now we want to see if we can verify the results that we saw on the dyno out in the real world. And so we're going to be using the V-Box in order to do this. the testing is going to be conducted exactly the same as it was in the previous video when testing a stock filter versus a performance air filter. So we're going to be using both of these filters with and without the charcoal filter, and we're going to be measuring from 20 miles per hour to 60 miles per hour on the same strip of road, doing 3 passes all in second gear, never leave second gear, foot flat on the accelerator, and we're going to measure that acceleration from 20 to 60 miles per hour as well as from 45 miles per hour to 60 miles per hour. So that 45 to 60 will be the top range of the engine, the higher RPM. The 20 to 60 kind of gives us an overall. Was there an overall improvement? The 45 to 65 looking at a narrower RPM region of the engine. All right, first up, 20 to 60 miles per hour with the stock filter. With the charcoal filter, we're looking at 9.01 seconds. Very impressive. You can see why people are going to want to take one of these bad boys on the track. 9 seconds from 20 to 60 miles per hour. From 45 to 60 miles per hour, 3.61 seconds with the stock filter and the charcoal filter. When we remove this charcoal filter and just use the stock filter, we're looking at 8.73 seconds in order to get from 20 to 60 miles per hour, and 3.46 seconds in order to get from 45 to 60 miles per hour. So a consistent improvement versus what we saw on the dyno. 3.16% improvement 20 to 60 mile per hour, and a 4% improvement from 45 to 60 miles per hour. So consistent results that we verify with the dyno. 3 runs out in the real world, 3 runs on the dyno, and it looks like the results actually do match up for the stock filter with and without the charcoal filter. Next, of course, testing the performance filter with the charcoal filter. 20 to 60 time of 8.81 seconds. 45 to 60 miles per hour in 3.49 seconds. Then taking the charcoal filter out, 20 to 60 miles per hour in 8.7 seconds. 45 to 60 miles per hour in 3.46 seconds. So once again, this was actually pretty close to the results we saw on the dyno. So about a 1.6% improvement on the dyno, 1.25% improvement, 20 to 60 miles per hour here with the performance air filter and no charcoal filter. Now, another really interesting observation between these two filters is that once you take this charcoal air filter out, the stock versus the performance filter really makes no difference. We saw the exact same real world times. So 8.73 seconds with the stock filter, 20 to 60, 8.7 seconds with the performance filter, 20 to 60, and both of them had the exact same 3.46 seconds to go from 45 miles per hour to 60 miles per hour. So removing this, these are basically equalized, and they give you the exact same real world performance results. Now, so far, all of this may sound very exciting, and you may be thinking, wow, this is a great idea. I'm going to remove my charcoal air filter. And so in order to bring down that enthusiasm, we're going to do a little math. And it's not math itself that's the reason why you're going to get bummed out. Math is exciting. It's what this math shows us that is the reason you're going to be bummed out. So we know that average acceleration is equal to the change in velocity over the change in time. In this case, we're accelerating from 20 miles per hour to 60 miles per hour using a stock filter with and without this charcoal air filter. And it was able to do so in 9 seconds with this charcoal air filter and 8.73 seconds without. So our change in velocity is 40 miles per hour, 60 minus 20, or 58.66 feet per second. We're going to divide that by time. In the case with this charcoal air filter, that's 9.01 seconds, and that gives us an acceleration, an average acceleration from 20 to 60 miles per hour of 6.51 feet per second squared. If you divide that by 32.2, that gives you acceleration in G's, 0.202 G's. That's the acceleration that this bad boy is capable of. Now, if we do the same math with the charcoal air filter removed, then we get 6.72 feet per second squared for acceleration. Divide that by 32.2, it gives us 0.209 G's. In other words, the difference between removing this air filter and having it within the air intake system is 0.0065 G's. less than 1/100th of a G in acceleration. You will not feel that. So people that said, I took my charcoal air filter out and suddenly I have all this power and it feels like it accelerates a lot faster, unfortunately, it is just not backed up by math. Less than 1/100th of a G in acceleration, you are not going to perceive unless you have some crazy sort of ability in order to perceive G forces. So unfortunately, real world, you're not going to be very excited simply by removing this. Now, another thing you might hear people claim in some forums, perhaps saying they got rid of their charcoal filter, is that they didn't see an improvement in power or acceleration, but they saw an improvement in throttle response. And here's why that's a pretty silly thing to say, because throttle response really isn't going to be dependent on this tiny little restriction within your intake system. So what's going on with your engine, and modern engines, keep in mind, are all using electronic throttles, so there's an electric motor that's dictating how open is this throttle valve. So on one side of your throttle valve, you're going to have atmospheric air. There's not really much of a restriction between this side of the throttle valve and atmospheric air, so that's what the pressure is going to be on one side. On the other side, closer to the engine, because this throttle valve is closed, you're going to be pulling a vacuum from the engine. That engine piston is moving down, it's trying to pull in air, but this is acting as a restriction. So throttle response is that time duration when you ask for an input, your input being pressing on that accelerator pedal and getting the response from this throttle valve. And so once this throttle valve opens, it allows that atmospheric air that's on one end of the throttle valve to travel to your engine. And that delay is that delay in response that you will feel in your engine when you press on the throttle and you don't have it immediately. It takes a little bit of time for that air to travel from this side of the throttle valve to your engine. Now, with electronic controlled throttle valves, this is purely going to be a function of how that throttle is mapped based on how the manufacturer set it. So they decide the parameter of how much throttle input equals how much open is this throttle valve, and that's where you're going to get your throttle response from. And you're going to have very close to atmospheric air. Yes, you have a few restrictions in the way, but it's going to play a very minimal role in affecting what is the pressure on this side of the valve. And as a result, it's going to play a very minimal role in what your actual throttle response is. So removing this isn't really going to change your throttle response. Having a differently tuned electric motor that opens your valve, that's actually what would change a significant amount of your throttle response. So for example, in the Subaru STI, you've got an intelligent mode, a sport sharp mode. You'll notice a significant difference in throttle response between those two modes. Depending on how much you press in the gas pedal, what you get in return is different because the electric motor is tuned differently. It's mapped differently for those two different modes. All right, so finally, what is my recommendation and what am I going to do with my own cars? So for me personally, looking at this, I thought it was very cool that we actually did see a measurable difference with and without the filter, consistent results on the dyno and out in the real world. I think that is super cool. Unfortunately, not something that you can actually feel. And so because you can't feel the difference and it's no longer emissions compliant if you take this piece out, for me, it's a very easy decision. I am leaving it in, no problem whatsoever. The Subaru Crosstrek is a slow vehicle. I cannot change that. It will remain slow, but interesting nonetheless. Learning with and without what the difference is to horsepower, torque, and how this thing accelerates. Huge thank you to Retail Me Not for sponsoring the video. Again, that link is in the video description. Thank you all so much for watching, and if you have any questions or comments, of course, feel free to leave those below.